Hello everybody, I'm Nick, and in this video you're going to see a pretty long discussion between me and partner software engineer from Microsoft, Stephen Toub. Now, you've probably seen Stephen on my Keep Coding podcast or through his annual blog post on performance improvements in each .NET version, and in this video I'm going to talk about the new C# and .NET version, performance improvements, as well as some AI in there. Now, before that, I'd like to let you know that I'm running a few online workshops on testing in .NET Aspire, where I'm live with all of you, teaching you how to do a certain thing for 2 days. Link in the description. Enjoy the video. So, Stephen, welcome. Long time no see. It's been 2 years since you were in some capacity with me on a video that was in the Keep Coding channel talking about performance. Here we're going to talk about .NET 9 and everything that excites you, worries you, that you want to focus on. So welcome to the video.
Great. Thank you for having me. It's good to see you again.
Good to see you too. So for those of you who don't know who Stephen Toub is, can you just introduce yourself and tell us what you do?
Yeah, I'm a developer on the .NET team at Microsoft. Been there for a very long time. And I'm sort of nominally responsible for the technical kind of oversight and direction of, in particular, the libraries that make up .NET, but then also have a strong hand in sort of performance end-to-end across the .NET stack. And also lately a lot to do with AI and making .NET great for developers, incorporating AI into their applications, which if people aren't thinking about AI right now, they should be.
Yeah, I see this initiative in Microsoft. I think I was speaking with some people, the two things in everyone's mind was security and AI. And of course, it's massive. I'm using AI heavily for my workflows and everything I do, even captions on videos and shorts. So yeah, it's a no-brainer that everyone should be looking at those. Even for my platform, DomeTrain, we're heavily looking into what we can do with it and how we can improve everyone's experience. I love the fact that everyone who's like principal or partner or distinguished at Microsoft, they say, I'm just a dude, or I'm just, somebody in that company. And it's like, you're a partner software engineer.
Yes.
Which means that's above senior, above principal, that's just below distinguished, right?
Yeah.
Yeah. So just so people understand, not just any. And of course, your annual browser stress test came out earlier in November.
My annual goal to break Safari or,
Yeah, we have benchmark.net and then Stephen Toub's performance improvements.net post. You've been doing this for so many years, 300 pages. I'm wondering if anyone at some point will just start printing them and publish them as books, just so people have them.
They're welcome to. It's probably not great for the environment, but
it's
it's a labor of love. It's fun, and it kind of gets away from me a bit, but it also, there are lots of reasons I end up writing it, but one of them is just to sort of explain in as much detail as I think is helpful why we're doing what we're doing and how it's being done, both to understand how .NET works, but then also more so that people can kind of learn from that and apply it to their own stuff. I'm really big into pedagogy. I've been a teacher in the past. I really enjoy it. It's also what I plan to do after I retire from Microsoft, teaching again. I love that aspect of what I do, and so I see it as a vehicle.
Yeah, my mother is a teacher, and from like a very young age, from a baby, I was in classrooms, and I remember how animated she was, like grabbing people and shaking them around to explain chemical bonds. She's a chemist, so my very in your face, like sort of aggressive teaching as well, in a way comes from her, because I think it gets people moving and learning. But traditionally, a very long book, at least in my age range, I'm 31, as I was growing, videos and video courses were more prevalent than books. The only book I've read, programming book, that was language specific was the Java cookbook in 2014 when I was a Java developer, in case people didn't know. Now I just consume tons of things through video, and you've actually made a few videos talking about performance improvements in .NET 9, and I think you did a live stream recently as well. I personally love that people get to understand from experts where Microsoft is coming from with all performance improvements, because traditionally .NET wasn't really a performant framework. I mean, it was fine in the pre.NET
Historically,
versions, but
I mean, it always intended to be high, efficient, but it wasn't the number one goal.
yeah,
It was a goal, but it wasn't like at the top of the list. And things like reliability, quality, usability, simplicity, speed of development were sort of priorities. And performance was certainly important, but for the first decade or so of .NET Framework's existence, it wasn't at the very top of the list. And with .NET Core, it kind of got promoted to being something that we care about, as much as security, effectively, which is also right at the top of the list. And it's just a key focus. It's we every time a change comes in, we're thinking about quality and reliability and security and performance, and we're weighing all of those and understanding the implications. When we started .NET Core, which was around 2013, 2014, I think we shipped the first version maybe 2016,
I think so.
2015, something.
I think
So yeah,
April or
um,
something.
the original sort of goal for .NET Core was it was really focused on being open source and cross-platform, and that was the two things. And then within the first year of sort of building it, performance got added to the list of this is another one of the central tenets, the central themes of the things that we're really caring about. And then, but we weren't talking about it so much, but it was something that was really important to me. It was important to others. And then so around .NET Core 2.0 was when I decided, yeah, we're not saying enough about this. I should write something. And I think I wrote 30 pages or something.
Yeah.
And then that wasn't enough. So .NET Core 2.1 came out and I wrote a little bit more. And then .NET Core 3.0 and I wrote a little bit more. And it's kind of grown since. Every release has had significant performance improvements. Just how much I've written about it has blossomed. At some point, maybe in .NET 10, I'm going to have to reverse the trend a little bit, just because it takes too many keystrokes.
Yeah, it's a meme now. Did you have any AI help writing that?
I had some AI help with the poems at the beginning.
Okay, the haiku, yeah.
Yeah. But it's AI still isn't at a point where it would do writing for me. I mean, I would get spell check and stuff like that, but at some point I could probably, here's a list of 1,000 PRs, write a 100-page blog post. Not quite there yet.
Yeah. I think the best thing about those blog posts and about .NET's direction in general is not the performance itself, but I think the democratization of the performance and exposing those APIs that are being added to us and teaching us how we can use them for our use case, which wasn't always the case. To have
there's a lot of and it's a good point, because there's historically, when we would add APIs, it would be very much focused on usability. And now a lot of the performance improvements have come about by us adding APIs that are, we still have the usable one. And then there's the one that is, well, if you want to eke out a little bit more perf, you can switch to this one. And it'll take you a little bit more code or a little bit more thought, but you'll reap all these additional benefits. And we're sort of okay now having both, whereas previously we only had this one. Or we'll ship a new API, but we'll really invest in ensuring that we can make it, that we'll make the design of it such that we know that we can tune it as we need to. And that's where a lot of the focus comes in. A lot of the focus also comes in the open source and the performance have in many ways gone hand in hand, because there are a lot of improvements that either we didn't think to make, or we weren't focused on making, or it wasn't an area of the code that was currently important to us. But because it was open source, anyone could come in and make the improvements that they cared about. They were profiling something in their application and they saw this as their hot path. And so they came in and submitted an improvement that we might not otherwise have made. And this allows for people to help themselves, which is pretty awesome.
Yeah. One of the things that you loved in the .NET 8 release was enable dynamic PGO. I think you said it's your favorite feature of the release.
Absolutely.
And I do think in many ways PGO goes under the radar. For people who don't know, PGO is the ability for your code to profile itself and then be able to optimize it. Is it the JIT that optimizes the execution of the program? Is that correct?
Yeah, so profile guided optimization has been around in many languages for and compilers for decades. Pretty much any of the major compilers out there support it in concept. But what .NET does with dynamic PGO in particular, which is the one that is just on by default starting with .NET 8, is the JIT basically, thanks to tiering, where it can compile your code multiple times over the lifetime of the application and basically hot patch in new versions of code over old versions. It can start with something that's unoptimized because most of the code in your application is a large chunk of it is only ever used once, if ever. So it doesn't need to spend a whole lot of time optimizing it. And then if it sees that it's being used more, well, then it could recompile it, and this time it could put some instrumentation in, and then once it's executed and gathered enough instrumentation, it can recompile it again, taking advantage of that instrumentation, basically the profiling of the code, the P in profile guided optimization, to then recompile the code again based on the characteristics and the behavior that the program was exhibiting, and use that information to optimize for those particular cases. So if you're making virtual calls on an iList, but the 99.999% case is that's actually an array, right? It can basically, it can specialize the code to say, if the type is an array, then do this specialized path, where it's devirtualizing and inlining and stack allocating and whatever else. And then on the else path, okay, well, then it falls back to just doing the normal iList thing. And it's a really powerful capability.
Yeah. I don't know the extent of, I mean, it's way outside my pay grade. Could it get to a point where it could recognize that, hey, I'm using .substring here, and then I'm doing an int to do parse, so I'm parsing an integer out of a string? Could it replace that potential with a span and a slice to remove that allocation?
That doesn't even need PGO. I mean, those kinds of peephole optimizations are things the compiler, the JIT, is already capable of doing. And there are many situations where it does, but it needs to be taught how to handle particular sequences. And every one of those is something that someone has to think up and implement. And we then, we're basically baking the behavior of a particular API into the JIT. So then we have to be very comfortable with what those behaviors are. But you can see these to a lesser extent with things like, just take something as simple as sequence equal, or string equal, right?
Yeah.
Very often, sometimes with string equal, you're comparing two sort of unknown string objects, but a very common pattern is you're comparing a non-constant string against a constant string, like, string dot starts with HTTP.
Yeah.
Or sort of thing. And those APIs, many of those APIs now are what we call intrinsics, where they're things that, yes, there's a full-fledged implementation in the library, but the JIT also is aware of the behavior of those APIs. And so in certain circumstances, it can choose to replace the call to the API with its own manufactured code. And so for a situation like string.starts with HTTP, because it can see what's being compared to, it can actually generate custom code specific to, quote, HTTP, and do whatever vectorization and unrolling and optimizations for those particular circumstances. Or in .NET 10, there's a lot of work being done by Andy Ayres right now on the JIT team around escape analysis and stack allocation of certain objects that would otherwise be allocated on the heap. And right now, a lot of that work is special case to arrays and array enumerators. So it's paying attention to those particular things, but in the future, it can be expanded to more and more things as well. So that those kinds of things can definitely be done. There's sort of a spectrum. You can start with just, hey, if you see this in your code, change it. And then you can graduate to, an analyzer. And the analyzer could even have a fixer where it searches all your code for that pattern and has a fixer that automatically replaces it. And in fact, that one actually exists. If you have int.parse string.substring, there's an analyzer that flags that substring and says, hey, you're passing this to an overload that takes string, but I see there's another overload that takes span. I can swap substring to as span for you. That one's built into the .NET SDK. And that's not specific to int.parse. It's anywhere you're calling substring and storing it into something that could have been a span as well. And then there's the compilers could be doing it for you. And at that point, it becomes a much bigger deal. But if the C# compiler, the Roslyn compiler is replacing it for you, or if the JIT compiler is replacing it for you, the bar for those kinds of optimizations is much higher. But every release you'll see things like that be done. There are also then occurrences you'll see where, to some extent, we can do some of it in library. In particular, you see this in LINQ, where we can flow information about query operators from one operator to another. We're returning IEnumerables, but there's a concrete type that is actually being returned, an internal type, and we can look and see what that type is in the next operator and then specialize certain sequences. So if you call order by.take, the take operator can actually see that the thing that it's being passed is actually an order by, which is lazy, so it hasn't actually been done yet. And then when it does the take, if you're taking one thing, well, rather than doing a full sort, it could just do a min or a max, whatever order you're doing. Or if you're taking three things, it could do a partial quick sort versus a full. And so you can do some of that specialization in library as well.
I see. Do you see a world where we have an AI-enabled JIT or just C# compiler?
Machine learning, sure.
Yeah.
AI, possibly. Compilers are one thing that you really want to be deterministic.
Very careful and deterministic. Yeah, that is why I'm asking, because even trying to build tools using AI or even machine learning, yeah, you can seed many things, but in many cases you can't by nature. And with GPTs
but possibly, certain areas of optimization. I mean, there's already been research in .NET on, could we use machine learning to fine tune things like inlining heuristics?
Yeah.
There's some really interesting research published maybe 6 months ago about using AI to generate assembly code from higher level language rather than going through a compiler. Could the AI learn this code would produce this optimized assembly? And it's not quite there yet, but it was, this space is progressing really quickly.
Yeah.
I can absolutely. There's already machine learning being incorporated into compilers, and at some point, I've no doubt that some aspects of AI will, very carefully, as you say.
Yeah. So since enable dynamic PGO was your favorite .NET 8 feature, what is your favorite .NET 9 feature? And I have a suspicion of what it might be. I think it starts with get and ends with lookup, but in terms of performance, at least.
You're right.
Yeah.
I have a handful. I mean, it's hard to pick your favorite child, but
no, it's
in
not.
.NET 9, I think. What's that?
No, it's not.
Oh, no. Okay.
According to my parents, it's always my sister. That's what I'm saying.
Got it. If I had to pick one, I mean, I have a handful, but probably the top one would be the support on several of the collection types, and in particular the dictionaries and sets for doing lookups with an alternate key. So there's, for a very long time, there's been a desire to, people use dictionaries as caches, as interning mechanisms, where you want to have some object that you give back. Maybe even like, you're parsing some data off the wire, and if the input that comes in is HTTP, then you want to give back the string HTTP. And so you want to cache that HTTP string, right? That's interning. But if to look up in a dictionary, you need to construct the string in order to give back the string, defeats most of the purpose. Not all the purpose, but most of the purpose. And so it'd be really nice if you could do lookups in these collections without having to allocate anything, without having to manufacture the very object that you're actually trying to retrieve, or the key in general. And so people have long wanted, in particular, to be able to do lookups in dictionaries with spans, and come up with very clever but complicated workarounds. Things like creating your own discriminated union type struct between, say, a string and a pointer with a length, and in a very unsafe way, very careful way, making sure that you can do these lookups with a custom comparison with your custom type, but you only ever store into the dictionary the one that wraps a string and never the one that wraps a pointer and a length, right? And you can do this, but it's non-standard and complicated and dangerous if you get it wrong. And so what .NET 9 adds, thanks to improvements to the runtime, to the libraries, to the C# compiler, to the C# language, is the ability to actually use a read-only span of char, for example, as the alternate lookup into a dictionary. So I can have a dictionary from string to people, or to person, and then I can use a read-only span of char to perform the lookup. And as long as I'm only doing, mostly lookups, I can avoid most of the allocations. If I actually need to store something new, well, then that read-only span char key needs to be turned into a string to be stored. But in the reading cases, the cases where there's a cache hit, I don't have to actually manufacture that thing. And so there's this mechanism via fun named method called get alternate lookup, or try get alternate lookup, where you can basically ask a dictionary instance, hey, I would like to perform lookups with the following key type. Do you support that? And if so, give me back the alternate lookup type that allows me to perform these operations with that alternate. And it's an extensible mechanism. You can make this work for any alternate key, but the primary one we were focused on, and the primary one we ship inbox built-in support for, is on all the string comparer types, being able to support read-only span of char as an alternate. But I would not be surprised if in the future that we saw support for using, read-only span of byte as a UTF-8 key to look up memory of byte or byte arrays or something, as the main key.
I could be wrong, but is allows ref struct use in that mechanism, or is that search? It is.
So yeah, and so before .NET 9, you couldn't have a generic parameter be a span or any ref struct. And so to make this work in a generic manner, we had two alternate paths we could pursue. We could have made this specific to read-only span of T.
Yeah.
And if we did that, we wouldn't have had to have relied on a mechanism for this, because we would have had APIs that were literally typed read-only span of T. And then the generic was the T, not the read-only span. But in order to have the lookup support anything, we really didn't want a hard code read-only span. We want read-only span to be something you could use, but not the only thing. And that then means that the generic needs to itself be the thing that accepts the span. And so it has to be allows ref struct. And so that's why we didn't ship it in .NET 8, because we weren't going to get that language feature that would allow us to sort of express this correctly end to end, or the runtime support to express this end to end until .NET 9, when it all kind of came together. But yeah, so if you look at .NET 9, you'll see all of the delegate, built-in delegate types, func, action, all the type parameters are attributed as allows ref struct, or annotated as allows ref struct. And then some of the equality comparisons that are generic, those are attributed appropriately. Enumerator, like IEnumerator, IAsync enumerator, they'll allow ref struct for their T. And then things like get alternate lookup, plus a bunch of APIs where there's sort of a common pattern to avoid boxing, where a method will take like a T state or a targ parameter, and often it's also accepting a delegate that accepts that, and then the method does something and calls the delegate and passes the state through, like concurrent dictionary dot get or add.
Yeah.
It has a delegate that is invoked to create the state. But if it only accepted objects and you wanted to pass a value type through, it would have to box it, and you don't want to do that. So there's an overload that takes a T state, and the add function, the factory, also accepts a T state. And when get or add calls that factory, it will take the T state arg and pass it through. So in all those situations, it's fine for that to be a ref struct because it's not being stored anywhere. It's just kind of being threaded through from the outer method to the delegate invocation. And so all those that we could find in the core libraries have also been annotated as allows ref struct.
Yeah. All of that is open to anyone can go and make something that allows ref struct. It's not like an internal mechanism. And that is a massive change in how Microsoft, I mentioned earlier, handles exposing things that you can use for performance. It used to be that if you wanted to do something really fancy, with pointers or whatever, because you're doing graphics work in C#, you have to enable everything as unsafe and then be very careful and whatever. It's like, here's a pistol, but we're gonna put 15 safeties around it. And now with collections marshal and span and stack unlock and so many other things, it's like, here's a bazooka, go. That's how I feel as a C# developer. And you can shoot yourself on the foot quite easily. I mean, if you're at that territory, you're already expected to be knowing what you're doing. So I say easily, but you're asking for it. You can't just accidentally write unsafe code. But
yeah, it's a fine balance to walk, and we're still figuring out what that balance is. I mean, we're very strict about anything that might resemble a bazooka in any way. You say,
yeah,
we put it off to the side, even if it's borderline. We put it off to the side. There's nothing memory or type unsafe about collection marshal.asSpan.
I was about to say that, and I wanted to use as an example iterating the array of a list through a span, and how if you change something in that list, things won't blow up the way a for loop would through a list. So
right.
yeah.
So so for those who don't know, collection marshal.asSpan basically gives you back a span to the used portion of the list of T's backing array. So if I have a list of T with a backing array of 8, but its count is 3 because there's 3 elements in it, asSpan is going to give you back a span of T for 0, 1, and 2, like the first 3 elements in the array. And this is not memory unsafe. You can't walk off the end of it. It's not type unsafe. You're not going to corrupt things in memory. But in particular, if someone were to continue adding to that list, at some point the list might grow. And what growing means there is it allocates a new array, copies the old stuff over to the new one, and puts the new one into the list. The old array is still a valid object. It's not going to get collected out from under the span. The span is keeping it alive. But any changes made via that span are not going to be reflected in the list of T. And so we didn't want to just add a .asSpan method to list of T, because we can't guarantee that if you're holding onto that span, you're not going to see these oddities. So we kind of, anything like that, even though it's by some definition of safe, we still put it off in system runtime interop services to basically like, hey, there be some dragons. Be a little careful. We are spending, in a lot of previous releases, you've seen a focus on performance mean we're making things faster, or we're adding new things to make them faster. There is a renewed focus, especially in .NET 10, and this has existed for some time, but more so in .NET 10, on not necessarily increasing the performance of things, but allowing you to get the same performance without having to resort to unsafe mechanisms. And then at the same time, revisiting how we help people to understand what is unsafe versus not. Right now, there's and this isn't new, this has been the case since the very beginning of .NET. There's this unfortunate dichotomy between things that are unsafe and require you to mark it as unsafe in the C# language, and things that are just as unsafe and don't. Um, uh, the most obvious example is if I have an inputter, if I have an int star, right, I can write to an arbitrary location in memory, an AV or seg fault, or corrupt arbitrary data. That is unsafe. Using int star requires me to use the C# allow unsafe blocks and the unsafe keyword. But I can do the exact same thing using marshal.write and system.intptr with the same amount of code, and it does not currently require me to
Yeah.
use the unsafe keyword. But it's just as unsafe.
Yeah.
So any of those things, like, they're buried off in system runtime interop services or system runtime compiler services, or they very clearly say in their name, be careful. But it does lack any kind of compiler support to place an additional guardrail to be like, look, you're using something that is very clearly unsafe, but you didn't have to say so in the language, so be careful. And so we're revisiting, like, what is the actual definition of safe and unsafe? And I expect that I don't know if .NET 10 or .NET 11 or out of band, there'll be some mechanism where you can basically change the unsafe keyword in C# to be the full gamut of stuff and not just the language constructs. But then at that point, there's a really interesting discussion around where is the line.
Yeah.
Like, there are certain things, like marshal.write is obviously one that would be annotated as such. This collection marshal.as span, it's that middle ground. Then there's other middle grounds like array pool, right?
Yeah.
Array pool, it's not type unsafe. It's not memory unsafe if you're using it the way you're supposed to use it, right? You're not. The type safety thing depends who you ask, but I'm going to say it's type safe, it's memory safe. But you can, you can have use after free bugs effectively, because you can return something to the pool and then keep using it.
Yeah.
So is that safe? You're not gonna AV, you're not gonna seg faults.
Yeah.
You're still the objects are still valid, but you might have a concurrency bug.
Yeah.
And so where do you draw the line? Is a static field unsafe?
Yeah. Could it cause memory leak as well? If you keep
could array pool cause memory?
Yeah. If you keep using something you haven't you released?
There's sort of a temporary one, just like you have with the GC, where your memory usage might grow until the GC runs. Array pool does have both limits on how many things will be stored, and also a collection mechanism where when the GC says there's memory pressure, it'll start ditching arrays. If the GC says there's a lot of memory pressure, the array pool will dump everything.
Right.
I'm giving up. Yeah.
But what about obviously what I'm going to say is in the unsafe class, not unsafe keyword, and that is unsafe.as, which is used a lot, and from what I understand, even abused within Microsoft because of how it was being used in, I think it's the extensions everything feature that had to be dropped and redesigned from scratch. But I keep seeing it many things in the .NET libraries use unsafe.as. Can you explain what it is and why it's used so much?
Unsafe as is a reinterpret cast. It's have a reference to something that is T1, and I want a reference to a T2, and it's just rename it, right? It's give me back the same reference but typed with the new thing. And so it's super powerful for things like if I'm working in generic code and I want to special case a particular type, I can say if type of T equals type of float, then unsafe.as from T to float, right? And at the runtime layer, when this is actually running, that's unsafe.as from float to float. It's perfectly safe. It's just giving in the type system, it's giving me back the same thing. Or if I wanted to reinterpret a a span of integers as a span of bytes, well, the implementation under the covers of memory_marshal.cast is effectively using unsafe.as, right? It's reinterpreting what was a reference to a what did I say, integer, as a reference to a byte, and just with a 4 times as long length. But if you misuse it, and this is why it is unsafe, you can end up with some really problematic situations. I mean, if I had a Nick and I reinterpreted it as a Steve, and then I start poking on things on the Steve, well, it's not actually a Steve, it's actually a Nick, and so I'm doing things on it that aren't appropriate for a Nick.
Yeah.
Right? But there's nothing that prevents you from doing that unsafe.as to go from one to the other. So it's in compiler services, it's called unsafe, but it doesn't require allow unsafe blocks in the C# language.
Yeah.
And it's funny, we'll get reports, we'll get issues open in .NET runtime from people that say, can you add XYZ API to the Marshall, for example? I'm like, well, you can do that in one line of code with a int star whatever, right? And they say, oh no, but I'm not allowed to use unsafe code. It's a policy that I can't use unsafe code. Okay. We should have a conversation.
Yeah. I understand. We mentioned dictionary as part of the get alternate lookup, which I keep typing as get alternative lookup because that's what I thought the name was, but it's not. How come the dictionary doesn't have a get or add method? That only... So you have a scenario where you want to check if something exists as a key, and if it does exist, you don't want to do anything, but if it doesn't exist, you want to add it. Sorry, and if it does exist, you want to return it.
There's nothing that prevents us from adding that. It just hasn't risen to the level. I don't even know if there's an issue opened proposing one. In general, we add APIs either because we see a strong need based on the code, we see the code people are writing, or someone asks for it and makes a strong case for it, and it's something we want to maintain, or it's something we need ourselves. And in that particular case, it just hasn't risen to that level. There's also downsides to those APIs. I know we have them on concurrent dictionary, and I think we have it on maybe immutable dictionary.
Yeah, you have them in another one too, but concurrent is the biggest one.
But there's overhead to that delegate if you're not using the more complicated T-state sort of approach, then you're very likely using a closure to close over state for the delegate. So you're allocating them on every call.
Yeah.
Even if you are using it, you still have a delegate, which means the add behavior ends up requiring a delegate invocation. So there's some overhead associated with that. And in some situations, PGO might be able to eliminate a good chunk of that overhead, but not all. So and there's also we think very carefully anytime we add methods anywhere, but in particular on types that are used everywhere and that are generic. So dictionary is generic T key T value, and it's the most common or second most common collection type. It's used in every single .NET application and service that's out there, with many different T keys and T values. And the way generics work is every time you have sort of a different combination that involves value types, you end up with a different stamp, basically, of all the functionality that's being used. And in native AOT, you often end up with a copy of the code for that particular generic instantiation, regardless of whether the method that is being used is used in that specific combination. So if someone uses dictionary of int, int, get or add, and someone else has a dictionary of int, long, but they don't use get or add, because of how things work, there's a good chance there's actually a copy of the getter add code specialized for int to come along, even though they never use it. Even with trimming and so on. And trimming continues to get better, and this issue becomes a little bit less over time, but we still have to think very carefully anytime we add functionality to these core types. And in some cases where we decide, it's worth it, we'll actually add the functionality as an extension instead of as an instance method, just to work around some of those issues. So it's not like we won't add it. It just hasn't been important enough for us to do so.
Yeah, makes sense. There's a lot of chat around LTS, STS, and how long they last, and their quality and their production readiness. And given your reaction, I'm not going to ask the question I had planned to ask. I'm going to ask, how do you feel about that? How do you feel about that?
This is being recorded, right?
Well, we need a sound effect for this. This is, I struck a nerve. Please be yourself.
Okay. Anything I'm about to say is Stephen talking, is not the .NET team, is not Microsoft, is not.
Disclaimer.
This is my personal opinion. The thing, I have no qualms with different releases having different support policies. I think there are very legitimate reasons why that is done. In terms of what it takes to support multiple things that are out in the wild at the same time, and the complications involved, and how many things you have to service, and this, support costs for the teams maintaining it, and for folks dealing with support calls and all that kind of stuff. So in an ideal world, would we not have the complication? Could everything just have the same support policy? Sure, that sounds, rainbows and unicorns. The thing that I struggle with is the effects of this. So first, just the fact that people believe that there is a reliability or quality difference between an LTS and an STS drives me nuts, and it's totally bogus. There is no difference. In fact, one could argue that STSs are more reliable than LTSs because they get more fixes than LTS does. One of the things about long-term servicing things is they don't get as many backports. They get the important ones, but they don't get as many because part of the value of them is keeping them stable. It's the same reason that .NET Framework gets very few fixes anymore, because its main value proposition is not changing.
Yeah.
And so the fact that there's a perception that STS is somehow less reliable or less quality, like, if it were up to me, everyone would upgrade to the new release of .NET every single time, the moment it's available. And it will be more reliable and of higher quality than the previous release. Obviously, bugs can sneak in, but those will be sorted out.
Yeah.
And a few fixes that will be, So I don't know what we could do better to fix those perceptions. I'm sure we could be doing something better to fix those perceptions. But we need to, because they drive me nuts.
Yeah. Do you, I don't know if you have these metrics, but if it has been discussed, it will be interesting to know. If you can't say, of course, don't say. But do you see a drop-off in adoption between .NET 9 and .NET 8, or .NET 6 and .NET 7, basically comparing?
Oh, yeah. LTSs are definitely adopted more.
Okay.
100%. I don't know the exact numbers. I'm going to make up numbers based on my perception. But if I had to make up numbers, it seems like there's maybe 30% of the .NET ecosystem that refuses or has company policy to only use LTS releases.
I see.
And there's maybe, again, waving my hands, maybe another 30% that doesn't care, and then maybe another 30% that is excited to always be on TIP. So I should have said 33% for each of those, but you get the idea. But yeah, there's a significant chunk that choose to stay on LTS, and that's fine, as long as it's being done for the right reasons, and reliability, quality is not the right reason. There is one reason that I think we could do better about, and I've been kind of politicking for this for a while. And again, just Steve's opinion, but we see a very real problem in the library space where, because of how libraries work in the .NET ecosystem, because of how NuGet works, um, let's say we ship system text JSON for .NET 9. So there's a 9.0 version of the system text JSON NuGet package up on NuGet with assets for .NET Framework down to 4.6.2, for Net Standard, for .NET, for .NET 8 and .NET 9. Targets all the things that are in support, right? You can use that. You have a .NET 8 application. There are really cool new features in the system text JSON 9.0 NuGet package, like improvements to streaming deserialization of multiple top-level JSON objects, which is really important in things like AI, because certain services that stream back results do so as multiple top-level JSON objects, right? So it's a valuable feature to want to use. So you have your .NET 8 application and you want to take advantage of this feature, and you don't have to move off .NET 8. You literally add a line to your CS project that's a package reference to system text JSON 9.0, and that version will be used instead of the 8.0 version that's in the platform. But .NET 8 was released on November of 2023. It has a 3-year support policy, so it ends up in November of 2026 when it ends. .NET 9 was released in November of 2024 with, I believe, an 18-month support policy, which means its support ends in May of 2026, which means that if you choose to upgrade that system text JSON package, then technically you lose support for that system text JSON component between May of 2026 and November of 2026, unless you move to .NET 10. And so you basically, if you're planning to stay on tip always, there's no downside. If you're not planning to stay on tip, then you eventually need to, but there's a 6-month window difference. I would much prefer it if the STS for version N didn't end before the support for version this one, so that there basically be no downside. And we ship .NET 8 in November of 2023, we ship .NET 9 in November of 2024, and their support both ends in November of 2026. If it were up to me, that would be what I would be hoping for. And the main reason I care about this is because of the effect on the library ecosystem. If I'm shipping my own library on NuGet, and I really want to use system text JSON 9.0 because of features it offers, but if I care about being adopted by folks that care about this stuff, I proactively can't, because there's this transitive dependency on the thing that I depend on. And so I have to limit what I'm able to do in my library based on some hypothetical consumer caring about that discrepancy, and that's unfortunate. So hopefully we figure out ways to deal with this. None of these things are set in stone. Support policies, this stuff have evolved over time, and I assume and hope and fully believe will continue to evolve based on market need. But that's the one thing if I could have, change one thing, it would be that.
Yeah.
Again, all of this is Steve's opinion.
Yeah. And disclaimer. And now there's Nick's opinion, which is it kind of feels like a big chunk of the work is, I don't want to say wasted every other year, but just not appreciated or not used that much. Like you have to wait 2 years to actually read the.
Yeah, that all of the work we did in .NET 9 will accrue to everyone that moves from .NET 8 to .NET 10. It'll just take them an extra year to benefit from it.
Yeah, it's just you're gonna use it for 1 year less as a user. So it's I think problematic for 2 reasons. Then if you increase STS to 2 years to cover that 6-month period, might as well do it 3 years and drop the dichotomy of the 2 different types of support periods.
Possibly. I mean, every incremental amount brings additional factors to consider. And so I'm not an expert in this stuff. there are probably a litany of reasons why what I think we should do as a minimum are problematic. And at the end of the day, will come back to bite me because I'm going to end up doing a whole lot of extra servicing work and spending less time building new stuff and more time backporting to other
Yeah.
releases and whatnot. So there's always trade-offs, and it's very easy for me and anyone else to sit on a pedestal and proclaim what I think should be done without fully realizing all the ramifications of what that means. But I, the happy medium will continue to evolve, I'm sure.
If we bring back, this is Steve's opinion, nothing to do with Microsoft, what would be the ideal scenario of support policies for you with durations? Yeah, and with support periods, basically whatever. If you had,
What's my rainbow and unicorn?
if you had, yeah, if you were the Satya, you could for some reason go all the way down to the .NET team and decide how they're going to support .NET. What would your policy be?
I don't know. I mean, there's people care about long-term support because it allows them to stay on a particular version for a long time. The longer they're on that version, the longer they're missing out on all the newer stuff that's happening. My ideal is that people are always on tip. People are always on the latest release of .NET. That upgrades are super simple, carry very little risk, are easy to do, and long-term support doesn't matter because you're always on the latest. So my rainbow and unicorn world is where everyone is just every December or every January is moving to the latest version of .NET, and this discussion doesn't matter because they're always supported and they're always benefiting from all the great stuff that's in the latest releases.
Okay, makes sense. I like the utopia.
But I understand
but
real world implications for why that doesn't
yeah,
fly. But you
of
asked what my ideal is. That's my ideal.
yeah. Makes sense. Makes sense. Um, I always wanted to know your opinion on what is the next span, and what do I mean by that? Span is probably the most viral and widely adopted feature that's released in .NET since Await Async, at least from what I've seen, and the passion that people have using it. And if you're able to understand it, then and use it, whoa, stack allocation, woo. What do you think is the next big thing? If you could guess, even if it doesn't exist, even if it's not on the horizon.
I don't know. I mean, those don't come around all that often, and they're generally born out of necessity. Um, and I'm struggling to think of what the next thing would be that permeates pretty much every single function that we write. We've had a few that kind of really impact how we think about writing stuff. Array pool, span, um, changes to the JIT that sort of change how we think about writing code because the JIT is able to do things that we were having to think more about. But more and more, I think there's a lot of it is just ensuring that the common patterns that people need have language or library support for them. And a lot of the language features that are being added are the kinds of things that end up being adopted everywhere. Like collection expressions fundamentally changes at least how most methods that I write involve a collection expression somewhere. Even if it's just open close for an empty. Right? And so I think a lot of the language features we end up adding end up permeating in that way. I think extension everything will have that kind of impact. And other language features end up building upon and improving, kind of continuing the journey. Like a lot of the work we've been doing in the language over the last several years, in C# over the last several years, has been building on span and making span more useful in more situations. And so those existing things continue to grow. it's hard for me to think if there's like what the next thing would be that would it, in and of itself be as cross-cutting as span was.
Yeah.
But I think there will continue to be lots of smaller rocks that add up to big things over time. Yeah.
Yeah, I'm gonna say the two cursed words in C sharp, which is discriminated unions, if they ever come around, or union types, or whatever we call that idea. Um, and if it's ever gonna come, even extensions, everything now is being broken down. Um, from what I understand, to reading at the notes, to smaller features and like a staggered release. If I pick that up correctly, I'm speaking next week with Mads, recording one of these actually in person. To
Yeah, the
see,
feature's being designed in totality right now.
yeah,
But there's it's difficult to get something that sprawling into a single release. And there are definitely diminishing returns on the sort of the long tail of stuff that comes with it. So methods, properties, uh, you add properties, and that like cuts off a huge amount of the reason that extension everything was desired. You add operators, and that cuts off another
yeah,
significant chunk of it. And then you start getting into the weeds, and yeah, those things will continue to come along later. But the biggest bang for the buck will, I assert, it will be hopefully be in C#14.
yeah, awesome. Since C Sharp has constantly, and .NET has constantly been improving its performance in many ways throughout the last versions, obviously it's going to be harder and harder to find, big wins, and maybe try to use old tricks in more places, use span in more places, use um, all the tools we have now. Every now and then I'm seeing blog posts of people. I actually read one recently that compared API performance of .NET 8 and .NET 9, and .NET 9 has regressed. I haven't run the benchmark myself to actually validate it, so I don't want to say, that's the fact, that's how it is, and I'm sure you've run your own tests as well internally. But on that note, do you feel like immense pressure now that adding new stuff, unless they're extremely optimized from the beginning, regressing can be perceived like really badly?
I mean, it is extremely rare with performance optimizations to not regress something. Um, the vast, it is the rare unicorn of a performance optimization that improves everything or improves something without harming anything else. The vast majority of them improve something at the expense of harming something else. And you choose to take it because the thing that it's improving is super common and the wins are really large, or the wins are really large, and the thing that is being regressed is rare and the regression isn't very big, and so on. But you add something as simple as special casing some really common situation means adding an if check to see if the thing is that situation, which necessarily adds an extra conditional for when you fall through to the fallback case, right? So there's some overhead that comes with that kind of optimization. Um, Dynamic PGO, right? It's a prime example of that. It's looking in your code to see what is the 90% case or the 95% case, or whatever the threshold is, and adding specialized code paths to handle those common cases. But when that common case isn't hit, you've paid for the checks, you've paid for the additional code size and the impact of loading that, and so on. So there's always trade-off. Uh, Unless you're like you have some dead code and you get to delete it, which is like a pure win. Even then, it can regress if it impacts things like alignment and things, end up. But stuff is all complicated. There are also, we make mistakes. I saw one recently that was about I think big integer, and uh, I think people are still looking into like what happened. Is this an alignment issue? Did we not measure the right things or whatever? But in general, they're not the mainstream paths, or else we would have noticed. It's usually something else, and then we look at it and we fix it. So I'm not too concerned about those cases. This is why we have a performance regression system, and we're constantly augmenting and adding to it. And if these things slip through, we find someone finds and fixes them. If no one finds them, then they probably weren't that impactful.
Yeah. But what about if no one fixes them?
If it's an issue and it's really impacting things and no one fixes them?
If it's not really impacting things, but you've identified it, but the trade-off of the new thing being added, for now at least, outweighs the degradation.
Oh yeah, we do that. Like we'll add something knowing that it's going to negatively impact something that no one uses.
Yeah.
Or one person uses it, and only if it actually we find that it's actually an issue. But this all ends up being on balance, right?
Yeah.
Are we increasing the greater good?
Yeah.
Yeah, I don't know if that answers.
Yeah, and you're very passionate about these sort of regressions as well. Like the first time we spoke, I'm pretty sure was when I made a video on regex, and it was when regex was starting to be source generated, and the pattern I was using was causing a regression, if I remember correctly. And you reached out to me via email, and you're like, "Hey, I literally wrote all of this code. Give me what you have. I want to see this."
Yeah. We absolutely we want everything to get faster, and when things don't, we want to understand why. We might accept, once we understand the reasons and we understand the impact, we might accept it and say, like, actually, this isn't a big deal, or if we were to fix that, we would really hurt this other thing, or whatever. And so there are always trade-offs, but we always want to understand what happened and why, because that will help us to determine what to do next. My dog decided he wants to join us.
That's okay. Hi, dog.
The comfy time. He likes to butt the door with his head and push it open.
Yeah.
Those kinds of observed regressions that actually ship are quite rare. They happen, and we fix them. They're quite rare. In general, they're much more common during the development cycle, and we usually notice them within a week.
Yeah.
Because we'll have some, if it's important enough, we'll have some test that starts running slower or consumes more memory, or the size of the application balloons, or it ends up impacting some ASP.NET benchmark, or it ends up impacting some WinForms benchmark, or deployment time benchmark to a Docker container, or whatever it is. We notice, and then we go and address it. And there's a litany of cases where our regression system will open issues, and we'll look at them and say, like, this is one, we improved 100 of our important cases by a millisecond, and we regressed these 3 cases by 2 nanoseconds. Fine.
Yeah.
And then when someone notices those 2 nanoseconds, and they write a blog post about it, and that's
I'll make a video about it.
But there are also cases, a lot of the benchmark.net is great.
Yeah.
But even then, you'll notice, like, when benchmark.net measures something, often it will report things like, this test is bimodal. Right? There are actually, or trimodal. Like, there's multiple different common results that come from this, and maybe it's alternating between the two. And these kinds of, when you're down at the nanosecond level, like, simple things like alignment, or where is the memory in the system, right? Those things can impact this stuff. And so 2 different people can measure the same thing and end up with different results. And we care about those kinds of things, but just because we care doesn't mean we're going to fix or even have a fix for some of them.
Yeah. I asked a friend who's a very big fan of your work, if you could ask one question, what would it be? And he said, how long before we can start allocating strings on the stack? I'm like, why was my question? Like, why are you that's your one chance? But and I think to maybe add some context, how long before we can probably, allocate a reference type on the stack as well?
So that already happens.
Mm.
Um, there's no explicit developer mechanism to explicitly stack allocate a reference type. You can stack alloc, primitives. You can create sort of fixed length, effectively arrays of primitives or anything unmanaged using something like or uh, even reference types. You can create arrays of the references but fixed length arrays of the references using something like inline array.
Mm-hmm.
So you can put the containers effectively
Yeah.
onto the stack. But putting the actual object onto the stack and being able to then pass it around is super dangerous, because if it could escape, then you end up with a dangling pointer, and that's very, very unsafe. And so the direction that we've been heading is, let's allow the JIT, or the compiler, to do the analysis to determine whether it's okay, whether some object escapes or not. And if it can be proven that it doesn't escape, well, then the JIT could decide to stack allocate that otherwise heap allocated object. And the beginnings of that did ship in .NET 8. So there's some basic escape analysis that happens currently only intra method, not inter method, where certain things can, sorry, .NET 9. Did I say .NET 8? I meant .NET 9. Where certain things can now be allocated on the stack. And this is significantly improving in .NET 10, such that if you for each over certain collections, the enumerator that would have otherwise been, if I for each over something strongly typed as an IEnumerable, you're generally, even if it's an array, generally you're going to get a numerator on it. And if you were enumerating the array directly, you'd use it struct based, or the C# compiler, the array case, would transform it into just a for loop. If you're for eaching over a list of T, you're going to be using its struct-based enumerator. But if that list of T were instead strongly typed as an IEnumerable, well, when you for each it, you're going to be calling its get enumerator that returns an IEnumerator of T, not its struct-based one, and you're going to end up allocating it. In .NET 10, in many situations, that enumerator can now be stack allocated, because in the typical for each case, the compiler can prove, the JIT can prove that enumerator does not escape. And so we'll see more and more of those sorts of things start to happen. But it'll be a long time before all the things across very complicated, method call graphs could be stack alloc, because that escape analysis is very complex.
I see. Back on a question that I've been waiting for a very long time to ask you, and there's another person I want to ask about this too. But there's recently, I think in the past year, has been an experiment in .NET called Async 2. And the other person is David Fowler, by the way, which I'll chat to at some point. I don't know how involved you were in this or how much you're aware of it, but if you are aware of it, can you explain what that experiment was and what it was trying to prove?
Yeah, and it's progressing from an experiment. I mean, there's real work being done to try and get it into either .NET 10 or .NET 11. But effectively, when you write an async method, and that async method yields, when it awaits something that's not yet complete, the state associated with that method needs to be stored somewhere such that it can be rehydrated, when the await completes and you keep running in the method. That effort is currently handled by the C# compiler. So the C# compiler rewrites your async method into a fairly complicated state machine, where you can if you kind of squint at the code and you imagine that every point where there's an await, there's something that sort of stores where you currently are, like a number representing where you currently are, sets up some callback to say, invoke this method again when you call back in, and then returns. And then there's a jump table at the beginning of the method that basically says, oh, for number 52, jump to just after the location where you returned and then pick up the result. So that's kind of the transformation that compiler does. And this causes the code for an async method to become pretty complex. And there's multiple pieces to it. There ends up being like an entry point method, which has the same signature as the method that you called. And then that calls into a helper in the runtime that calls into the thing that pushes the state machine forward. And there's all this complicated stuff that's generated by the C# compiler. This has a couple ramifications, but one of the most impactful is that it ends up inhibiting a whole bunch of optimizations that the runtime would otherwise be able to do with a normal method. The most obvious one being inlining, where if I have a really simple method and all it does is await some other function, if that was a regular method, that method would be inline like that. It's small enough, it's compact. The inliner say, yeah, sure, I'm just going to inline this thing. But once it's an async method with an await in there, the code becomes this complicated thing that's no longer available for inlining. And that then has ramifications on how developers that care about sort of the minutia of performance, like me, we end up significantly changing how we write our code to accommodate that. So if you look at one of the best examples is the method in our WebSocket implementation and manage WebSocket, the implementation of receive async. I think the function it's a private helper called receive async core or something like that. It is a giant async method. And there's a comment at the top of the method that says something like, yes, this is huge. Yes, this seems not maintainable. Yes, best practices would be to factor this into multiple pieces. But in doing so, it's very likely to increase the call chain through async methods, each of which are going to end up with more overhead and with more task allocation. And we're choosing to manually inline functionality into this large method rather than sort of best practices for software development of creating these reusable small helpers that we can piece together into this large thing. And that is a downside to this transformation being done in the C# compiler. And then there are other methods. Some of these methods get so complex that some of the other optimizations, constant folding or strength reduction or whatever else that the C# compiler might otherwise, the JIT might otherwise do, throws up its hands. It's like, I give up. And so the code quality that results for some of these async methods just isn't as good as it could be, and it forces developers to care about this stuff. Not the 90% case, but the 10% case, to write some of their code in a different way. So what async 2 does, and the only reason I snickered at the name is some people assume that async 2 represents a new keyword or something like that in the language. It does not. No. All it is effectively moving equivalent of that transformation down from the C# compiler into the JIT. Yeah. That's it in a nutshell. And instead, the C# compiler would generate if you look at the IL that it generates, it would look basically like the C# code you wrote. Instead of doing the state machine transformation, where there's an await, there would be a call to some intrinsic function, await, right? And so the code looks the same as what you wrote in C#. And then when the JIT gets it, well, then all of its optimizations around things like inlining sort of just work. Yeah. Right. And then it's up to the JIT to do whatever transformations it needs to do to persist the state for the next time around. And I'm saying just like there's a lot of work associated with that and complications associated, but that's it in a nutshell. That's what async 2 is. It's moving the responsibility for how that state is persisted from one place to the other. And what it allows is things like if the JIT, if I have an async method that returns a task of int, and the method synchronously completes and returns 1000 as the result, there's still a task allocated to represent that 1000 being returned. But if the JIT is doing it, and the JIT sees that it calls from one async 2 method to another async 2 method to another async 2, and they all complete synchronously, it can eliminate that intermediate step of creating a task to wrap the result only to then unwrap it in the caller. It can just call them as if they were synchronous methods completely.
Yeah.
And so there's significant efficiencies, in some ways very similar to if you were using value tasks religiously across your whole call stack. Um, uh, but it also helps in other ways. And in particular, one of the main areas that async 2 really helps is with exceptions. Um, and we often say, oh, it's an exceptional path, like we don't care about perf. That's not entirely true. Like we don't want we want everything to be fast. We don't invest a lot of effort in general hyper optimizing exceptional paths, but exceptional paths in certain situations can be devastating. And in particular, in large scale services, if there's an outage or some sort of hiccup or something, you can see these exception storms where um, an exception gets, so the network goes out and an exception gets, that's a bad idea. Let's say that something causes the CPU to become really inundated, and that causes something to time out, and that throws an exception, and that causes, because it's an exceptional path and there's the overhead of throwing an exception, that pushes the CPU a little bit harder, which causes something else to time out and throw an exception, which causes something else to throw an exception, and now you get all these exceptions getting thrown, and now you have these storms of exceptions that sort of end up dominating. You get this burst of problematic activity, and this is made even worse with async, because if I have async method A calling async method B, calling async method C, and there's the weights all the way up, the way exception handling and async methods work is the exception is propagated via the returned task. So there's a big try catch around the whole async method body generated code that catches any exception, stores it into the returned task, and then when the caller awaits that returned task, the exception ends up getting rethrown. And then that async method catches it and stores it into the return. And so something that might have been one exception throw and catch ends up being however many exception throw and catches as you have method calls deep. So if I have A calling B, calling B, calling dot, 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 dot through Z, I've got 26 exception throw catches, whereas previously I only had one. And in .NET 9, we made exception throwing catching in general significantly faster, 2, 3, 4x, depending on how you measure. And then with async 2, we can eliminate, not only do we get that for all async things, for all things, if I have that 26 nested deep call thing and the exception propagates, it goes back from being 26x to just 1x. Yeah. And so this should also significantly help in those situations. So that's really the impetus behind it, and the idea behind it is moving the transformation out of the C# compiler. The C# compiler will forever still be able to produce the old generated code, because it will only be able to do the new thing when it's targeting .NET 10 or 11 or whatever version exposes the right runtime support. The compiler would then light up and say, oh, okay, I can switch to the new thing. But as long as .NET Framework and .NET Standard and whatever around, it'll always have the old thing as well. But eventually, the majority case will be you're generating code where the runtime is able to handle this and leave the compiler out of it.
I see. I remember a time where you couldn't use a wait on the exception block, if I remember correctly. I think it was a version gap, or was the final block. But one of the two blocks, you couldn't even use a wait async. So I can imagine how tricky it must have been to implement in the first place.
There's a lot of rules at the IO level about what blocks you can jump in and out of, and so it requires extra code to set up. Okay, I'm going to set some state, and I'm going to jump just before the block, and then I'm going to enter the block, and then I'm going to,
Yeah. You mentioned JIT quite a bit, and obviously async 2 is moving that into the JIT. How would that affect native AOT that doesn't have a JIT compiler?
Well, it actually has effectively the same JIT compiler. It just uses it at build time instead of runtime.
So to generate the code, the native code.
Yeah. So 99% of the code, basically all of the assembly code that is generated for AOT is generated by the JIT.
Oh.
It's just used at a different time. It's not used at runtime, the JIT doesn't ship as part of the native AOT application, but it's there in the tool chain. And so when you publish AOT, the native AOT toolchain is effectively calling into the JIT to get it to generate code for things then, instead of shipping the JIT and using it at runtime. And so the vast majority of what the JIT is capable of doing just accrues to native AOT. And all this async 2 stuff should, waving my hands, sort of just work as well. The main things that where there's bifurcation, and it's less about what's being used and more about how the JIT is configured, is things where the JIT is relying on knowledge of the current machine to decide what code it generates, which it can't do for native AOT, because you might build over here and then run over there. And so this shows up with things like what special instruction sets are available. Like if I have code that could benefit from using so I'm looking at tensor primitives, and I've got a method that can use vector 128 or vector 256 or vector 512, depending on what's currently on the machine. Well, the JIT will look at what's currently on the machine and will choose the best one for the current situation when it's being used at runtime. When it's being used at build time, it has to be told what instruction sets are going to be available and assume sort of a minimum level.
Yeah.
And only if you're going to be running on a machine that has AVX2 or that has AVX512 or that has SVE, you can then tell it when publishing your AOT application, okay, you can assume these things are available. But otherwise, you might end up with a discrepancy between the code that's generated.
I see. Yeah, that makes sense.
You also currently lack things like the dynamic PGO. There's no dynamic when it comes to AOT, because you're not the JIT's ability to do tiered compilation doesn't exist when it's generating it once ahead of time.
Yeah, makes sense. Regarding .NET 10, any big upcoming performance improvement that you're working on, or something you've spotted and you say, this could be better?
There's been a litany of improvements. There's no one monstrous kind of cross-cutting thing that I can point to, but I think I probably said before, like, in order to facilitate my writing the annual blog post, I just have a draft email sitting in my folder all year long.
Wow.
Where I just add and categorize links. And I actually was adding to it this morning, and there's about 300 links in there already to PRs that have come in since, say, August, that have the possibility of improving performance in somewhere in one way, shape, or form. And about a third of them end up being in the JIT, and those have the opportunity to sort of impact everything. And then maybe 70% are sort of, improving string dot whatever over here and improving GUID whatever over there. And so then there's kind of spread out. I think from a JIT perspective, there are a bunch of improvements that will help in certain circumstances. As I mentioned, there's a lot of work being done around stack allocation, which is really cool. That should help in real situations in .NET 10. We should see that reducing allocation. And then these things have a snowball effect when we know that an allocation can be eliminated in a circumstance that then changes how we write code. Like, we'll write specialized code to deal with the fact that something would be allocated. Well, if it's going to be handled by the runtime, then we don't need to do that, and we can do the simpler thing. And if we do the simpler thing, then we can do the more, we can add this performance improvement that we couldn't have as easily done before when we had all this complicated stuff. So these things kind of add on, and I expect to see that here as well. There have already been improvements to frozen collections. There have been improvements to search values with new specializations being added for different scenarios. There have been improvements to primitive types. There have been improvements to tensor primitives. And as always, some of these come in from our team, some of them come from elsewhere in Microsoft, but a bunch of them come from the community. In general, in past releases, it seemed like anywhere from 15 to 20% of the performance improvements that I end up covering in the blog have come from folks external to Microsoft. And just from glancing through the links that I've already accumulated, that pattern seems to be holding, which is pretty cool.
Yeah.
So I'm expecting it's going to be more of sort of lots of improvements across the board rather than giant investments in an area. I think it's unclear whether the async 2 stuff will land in .NET 10 or whether it will land in .NET 10 as a preview, whether it won't land at all and will be .NET 11. But that will be one big rock that should have some pretty meaningful impact in a bunch of situations.
How would that look like consumption-wise on the async 2 stuff? Would the code
do our
change?
job right, should be zero impact to what anyone ever writes, other than they don't have to be as thoughtful about how they nickel and dime performance.
Okay.
Our goal is zero impact to the developer. They don't have to change their code at all.
That'd be crazy.
Just gets
like, wow. Like if you manage to do that,
that's our goal. And there are certain things where we might have to make some sacrifices to achieve that goal. Like in the early investigation stages, especially for really small method bodies, there's some overhead that we pay for some of the state management that we do around async locals. And in particular, when we choose to revert changes to those. And for really small method bodies, that overhead can add up. And so there was a debate like, oh, well, if we don't care about maintaining that exact behavior, we could get, in some situations, 20% above and beyond the benefits we were already getting from async 2, we could get another 20% reduction in overhead or something. But it's going to change behavior, and it's going to make people write their code a different way. And so we have to evaluate those trade-offs. And my position is we're already getting benefits from this, even though I love performance. I think bifurcating the ecosystem based on in terms of how they have to write code is a really, really, really impactful thing that we need to think not just twice about, but like 100 times about. And so we can get most of the benefits without incurring that. I'll choose that every day and twice on Sundays.
Do you see a world where you have like an attribute or something to be able to mark a method and fall back to the previous behavior? Is there a reason for the 2 async behaviors to exist? Because if I remember correctly, on the async 2 benchmark that was shared, async 2 was performing better in some cases, but worse in others. So would it be up to the developer to choose what's going to be used?
I suspect that by the time we ship, there won't be any reason for you to want to opt into the other one. I could be wrong. Or it will be a small enough reason that on total it's simply not worth the maintenance headache of figuring out which methods you want to attribute with that or whatnot. As I mentioned, for at least a very long time, the compiler is going to have to maintain the ability to do the transformation itself because of all the targets that don't require it. And so in theory, you could imagine an attribute saying, even though you could do it, don't. But I suspect we wouldn't want to do that unless there was a very strong reason, which I'm currently not seeing.
I see.
And any more so than there's no flag when the C# compiler makes a change to how it generates the code for those state machines, which it does several times a release. There's no flag that allows you to say, oh, no, I want to go back to the previous code generation. Right?
Yeah, makes sense. Cool. Well, that is all the questions I had on the whole .NET 9 release and performance. I do have a couple of goodbye questions, which the first one is, what is your favorite NuGet package that is not from Microsoft?
The package that's not benchmark.net.
Okay, yeah, of course. Sometimes I forget that it's not benchmark. It's not from Microsoft because it's used so much and presented from Microsoft so much. So I'm like, that's Microsoft, but no, it's not.
That I like every new, I have like console app 127 just from do file new whatever, and probably 70% of them have a reference to benchmark.net.
Yeah.
And these days, the NuGet packages for talking to various AI services.
Yeah.
The OpenAI package or whatever.
It's so insane, the type of growth that all of that sector is seeing. We've been trying to create like AI related courses on my platform, and by the time we start drafting, writing the code, recording, and we're on editing, everything is different and we have to scrap everything. It is insane.
Yeah, it's been a whirlwind. I've been thinking about AI with .NET for a while now, and everything I thought I knew yesterday is wrong today, and everything I think I'll know tomorrow, I'm wrong about that.
Yeah.
Um, there are patterns that are emerging and certain things that seem to be fairly stable and other things that are constantly changing, and
Yeah.
just figuring out how to partition which things fit into which category. Like the models themselves, they're improving, not even daily, like by the minute.
Yeah.
And is this something keeps popping up on my screen?
Okay.
Um, uh, they're they're improving constantly, and decisions that we make based on the capabilities of the models today are going to be wrong in 3 months. They're going to be more powerful, cheaper, faster,
Yeah.
bigger context windows. Things that we wouldn't do today because we're limited to 128,000 tokens or whatever the max currently is for some of the widely deployed models. Tomorrow it'll be 2 million tokens, and there'll be caching involved so that you don't have to pay for the 1.9 million of them that you put into every request.
Yeah.
And it's the stuff is evolving so fast, but the things that you can do with it, the patterns that you use to access with it, there's some I think some stability there.
Yeah. What's the coolest thing you use AI for?
Uh, there are some. I'm not sure they're cool, but because they're constant for me now. I mean, I live and breathe by Copilot's code completions.
Hmm.
I mean, it seems like I forget I'm relying on them, and then I go to a machine that I don't have it installed, or I'm on nightly builds of Copilot and or VS, all of VS, and every once in a while there's a hiccup and something gets broken and it's not working for me, and I viscerally feel like, wait, what? Because I've changed my workflow
Yeah.
to based on knowing what it will do and what it won't do well, and incorporating that, and so I'm like, wait, how do I do this again?
Yeah.
And a lot of that's just around speeding me up. It's about things where the more you do it, the more you get familiar with what it will do well. And so like I will if I'm writing something and I know what I want to write, but it's a paragraph of code, and if I just pause for like a half a second, I'm 99% sure that it will complete to exactly what I was going to write. Right. Um, those I love that. And that's been awesome. Um, I I do just a lot of I use uh, Copilot or ChatGPT or any of these things basically as my web browsers now. Um,
Yeah.
so I do a lot of that kind of searching. I do a lot with Copilot within Teams. Um, I mean, just relying on some of the things that it does implicitly, like the transcripts and calling out places where I was mentioned or things like that. But I'm invariably I'll show up 15 minutes late to a meeting and I'll say, hey, what was covered in the last 15 minutes? Was I mentioned? What do I need to know? Or I no longer have to pause and say like, hey, what was the thing? What was the acronym you just used? Explain that to me. I'll just say, what does blah 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 mean?
Yeah.
And like, I know. Or uh, who is the so and so that was just mentioned, and what is their reporting structure, and I'll find out how they relate to me. Like all that stuff is just sort of now built into my workflow and is awesome. Um, so yeah, it's sort of changed how I operate on a daily basis. On a personal matter, there are certain things that I love. I love Suno.com.
Yeah.
Um, and they released their V4 model a couple months ago, which is spectacular.
Yeah.
I'm sure V5 will come out of like, oh, V4 sucked, but
Everyone is releasing models like crazy. Even ByteDance now released a pretty good model. We have Grok, you have everything.
yeah. Um, Even things like I was doing presentations for .NET 9, and so I was going up to Copilot or Dolly 3 and be like, I need an image of blah and put that into my
Yeah.
PowerPoint. Like it's both useful and fun, and yeah, even things like in Outlook, I now have the background is a AI generated every 4 hours. Outlook has this feature now where every 4 hours it can generate a new
Yeah.
AI image based on your location and the weather, and it's just fun. Like,
Yeah, I'm really into video generation now with Sora.
I haven't done that yet.
So bit of a behind the scenes, but I really like writing lyrics and playing music. I can't write music, but my girlfriend is singing. She's really really good. So I've been writing her songs. We were recording them, and then I was trying to make like music videos from stitching Sora clips. And other than a
Fun.
few blips where smoke comes out the wrong way, it's pretty like really good.
Yeah.
Really,
Yeah, it's a
really
lot of
good.
fun. There's a lot of fun to be had here. There's very a lot of creativity stuff. With my kids love, like, I want a picture of a kraken attacking a Lego building.
Yeah.
Like, okay, let's see what it does. And oh, that's awesome. Let's do it. Yep.
And then they walk in the room and you're like painting it, like faking you're painting it.
Um, so yeah, it's a lot of fun and it's super productive. I live and breathe I basically am in either Outlook, Teams, or Visual Studio
Yeah.
all day long. And I use Copilot in pretty much all of them, plus Edge. I also like I very frequently, if I'm, right now I'm in the browser with Discord, and if I was going to look something up, I click the little button in the top right
Yeah.
and just ask my questions there. Um, yeah, it's remarkable. It's funny, we did a cruise this past summer, and we weren't paying the ridiculous pricey rates for internet, which I was glad for because I didn't want to spend my time on my phone.
Yeah.
But for whatever reason, there were some holes in their firewalls where, they have Wi-Fi for the whole ship for you communicating with others, and um, uh, WhatsApp still worked.
Yeah.
And WhatsApp now has, Meta's AI built into it where you can chat, and that still worked. So I could still
Oh,
basically ask questions as a workaround for. And so my kids wanted to know something, and I couldn't browse on the internet, but I could ask the AI,
I was trying
and
to
then I have
find.
to use my.
I was trying to find. I have a few Starlink satellite things that have internet. I have a Starlink Mini. I was in Peru for a month, and I had it on my backpack on like the straps it has on the bag. I just internet everywhere. It was crazy, crazy. If I wasn't that cruise, I'd be just selling internet access. Yeah, give me a
They
fiver.
may not have let you onto the boat with it, but yeah.
Yeah,
Yeah, it's a remarkable. It's changing how I interact with things on a
yeah,
daily basis. And for the most part, right now, I use, AI in coding. I am pretty pretty focused on chat completions as just sort
mm,
of as part of my daily flow. But I have been using the chat capabilities more and more. I and Some of it is super helpful and remarkable. I put up a PR a few weeks back, maybe December. We have system.memory extensions
hmm
in .NET, which provides a lot of extensions over spans in particular. And there are a whole bunch of methods there, like index of, contains, index of any, and sequence equal, and so on. Most of which are constrained, where T implements I equatable or I compare or a comparable or such thing. Most of those, a few of them, a few of them did, but most of them did not have an overload that just accepted an I equality compare. Um, which means that there are certain T's you just can't use it with. You can't use it in a generic context where the T that you have isn't also constrained, and you can't use it if you have a custom compare. So one of the things that is in .NET 10 now, and will be in the first preview, is overloads of basically the full set of APIs on memory extensions, where there's an overload that now also takes a comparer, and that meant implementing like 40 or 50 different methods that were structurally very similar to the non-equality compare and very similar to overload and very similar to some of the other ones. So I wrote like two of them, and then a combination of chat and code completions basically wrote the rest. Um, and I reviewed them, and I went through every line and reviewed them to make sure, but it saved me a ton of copy paste and manual editing
Yeah.
and remembering to change this or that up. And instead I could just have it generated for me, and then I could go and review it and
Yeah.
make sure that it was actually what I wanted. And then for the tests was even nicer. There was, we already had tests for all of the existing overloads, and I just wanted to augment all of the existing tests. The test might have been calling 3 different overloads, and I wanted to augment each test with another call to another 3 overloads, right? And once I implement, and each file maybe had like 20 or 30 tests for where each one was doing something different with 3 of these overloads, and I wanted each one to sort of replicate that structure, but for the other 3. So I implemented 2 of them, and then I literally typed a single prompt into the chat. It was like, the first 2 methods in this file have been updated to do the following things. Please, I'm still nice to AI, please replicate that structure across the remainder of the tests. And it took about a minute before it came back. It was perfect.
Yeah.
Except there was one method, there was one test at the end of the file that didn't follow the same structure, and so it didn't update. And so I went and updated that one myself. But literally everything else it did in other methods was exactly what I would have typed.
Yeah.
It saved a bunch of time.
Literally how I code is with code completion, and I'm asking, write this as if you're Stephen Toub, and it just gives using read-only spans.
I mean, the biggest problem that I have today with that sort of thing is the models are still playing catch up with all the things that we've done. And even when the model was trained after, a certain release of .NET or C#, it's still sort of heavily weighted towards the older stuff in terms of how much is available. So it can, for things where I am trying to use the latest and greatest stuff, it can be challenging. The most obvious examples are, and another thing I do is, we now have Copilot integrated with GitHub, and in Visual Studio, you can ask for a code review.
Yeah.
And so I just put up a PR for adding a link for iasync enumerables inbox in .NET 10. And I asked for a code review, and some of the things that came back were, this won't compile because you're using open bracket, close bracket to initialize a collection.
Because the feature just,
well, you don't know about C# 12 yet, or whatever release. So I think we still need the models to kind of be more up to date, or for the context windows to be large enough that we can use RAG to inject the entire C# specification, or whatever. So that stuff is still evolving, but it's got a ton of progress.
Yeah. Have you used Cursor?
I have. I don't spend a whole lot of time in those environments.
Yeah.
I mean, even if they're useful, I know a bunch of folks that purposefully go to ChatGPT to do things, and I still find myself gravitating towards sort of the in situ support. So if I'm in Teams, I use the Teams. If I'm in Edge, I use the Edge thing. If I'm in Visual Studio, I use Copilot. So I haven't gravitated yet towards going to external things when I'm not already there.
Yeah.
Wait, you said Cursor.
I said the ID Cursor. That's
right. I thought you were talking about GitHub. What do they call it? Not OpenAI's Canvas. Canvas is what I said.
No.
When you said Cursor, I thought Canvas. Have I used Cursor? Yes, I've used Cursor. But even with VS Code, I still prefer working with Visual Studio. And especially with the ability now to choose different models in Visual Studio, Claude or Boro or whatever. I haven't found any reason to use Cursor.
I understand. I do also understand Microsoft and VS Code. It's a fork, right? So I've talked about this in the past, but I think eventually VS Code will just implement everything that Cursor has implemented natively. It would be silly not to. Fingers crossed. Yeah, I've used Cursor as well, and it's fine, but I go back to Rider. I'm in a weird situation where I don't really like using these AI aids unless I need them for specific things. So let's say I want to automate a big task, I'll use them, but I won't use code completion or this, and maybe I'm silly for doing it, but it's fun to have predictable keystrokes and know exactly when to tab, rather than I have to see that this appeared, I have to scan, is it what I want, and then I have to press tab. I tend to be faster the other way around, but I use...
Yeah, for me, it ends up, I end up, I will often end up sort of ignoring the ghost text that appears
Yeah,
until either A, it catches my attention and I realize I can just hit tab and it will do exactly what I was going to do. Or what's more common for me is, as I mentioned, I've changed my flow now, where if I do something where I know it's going to, there's a 95% chance that it's going to give me almost or exactly what I want, I will just, I mean, I'm a fast typer, but I will like pause
yeah,
for a split second and give it time to generate a completion. And I'm waving my hands at this, but I would guess that 90% of the time that I do that, it gives me exactly what I was expecting it to give me. And that's because I've sort of trained myself, or it's trained me to know when it will do a good job versus
yeah,
when it won't. And that's also constantly evolving. Like, it's getting better at things that it didn't used to do well at. And so I'm ending up pausing more. But a lot of what we do in our daily development are very routine, structured things, and replicating patterns from over here or from over there, or taking something from over here and tweaking it to be over here. And in those situations, it's exemplary. I mean, it's amazing. Code refactoring that, I have a cascading if else and I want to make it a switch or something,
yeah,
right? It's super good at that. And I just start typing out switch and a little bit, and then it fills it all in. And I still check it, but in those situations, I know I'm just gonna like take a sip of my coffee because it's gonna end up saving me a minute instead of
yeah,
having to type the whole thing out. And I love that.
yeah.
It's awesome.
Well, great. That's all the questions I had for you today. Thank you very much for joining for this video. It's always a
Thank you.
pleasure. And I mean, this is true, I guess, for every person in Microsoft, but your input in your specific vertical is always unique and irreplaceable. So thank you very much for even taking the time to talk to the community and me and talk
Oh,
about
this
all
is
of
fun.
those
I love
things.
it. From my perspective, .NET is about, there's a few of us that are paid to work on it full time, but it is a community effort, and it's all about what everyone's doing with it. And if people weren't using it, if people weren't enjoying it, if it wasn't meeting people's needs, then I no longer have a reason to work on what I'm working on. So it is all about uh, all of us enjoying this and communicating and learning from each other. Uh, and that's wonderful. I love seeing community PRs come into .NET Runtime, not only because I know it's making .NET better, because I know invariably I'm going to learn something, and
Yeah.
that's awesome.
Awesome. Again, thank you very much for joining me. And to all of you, as always, keep coding.